Excellent. So welcome back to the last part of our introduction to data science. So today all we're going to do is just talk a little bit about using Excel. Excel is an excellent tool to kind of get your hands on a piece of data and a data set, and it's also a very commonly used tool throughout the business world. So I think there's going to be this interesting transition from using Excel to Power BI, which is kind of going to be the discussion of our next topic. But Excel and Power BI are kind of synergizing, where you're getting a lot of tools that are being developed for web applications and pulling information from the cloud, actually pulling into Excel. Great. So what we're going to do in this demo is we're basically going to build ourselves a histogram, talk a little bit more about what a histogram is. We're going to create a scatter plot, and then we're going to deal with the t-test. So hopefully it'll be relatively painless, and it should be fun. All right. So the data set that we're going to get is going to be a data set that I just randomly grabbed from the UCI machine learning repository. And I know I mentioned cars multiple times in the earlier videos. I'm actually not a car person, so I don't really know too much about cars, but that's what the data set's going to be on. And just because I wanted to kind of talk about this data being kind of agnostic, so data science being data type agnostic. And so pretty much any tool that you want to apply at this level 1 stuff, you can just kind of apply it to whatever data set you're looking at and see what comes out to see how you want to analyze it. So that's going to be our approach. So let's go ahead and get started. So I'm just going to go ahead and start up Excel. And as it starts up, I'm just going to create ourselves a blank workspace. All right, great. So there's our blank workspace. I'll full screen it. And there's a bunch of different things that you can do. What I'm going to do is I'm going to just go up to this data piece up here. Click on that. And I'm going to go over, and there's a bunch of different ways you can import data. So obviously we could just type in our data, if we wanted to, just like you normally would. Like, let me just make this a little bit bigger so we can all see it. All right, so we pulled up our Excel spreadsheet here, and obviously we could just enter information like we normally would. So we could just be typing in something like ID, and then we'd say 1 and name, platypus. I don't know. So we might be talking about different pieces, but a lot of data is already out there. And so as a data scientist, it's not really our job to set up the data structure. Often we'll have the data structure already in place, and we want to be the ones that are manipulating it and organizing it afterwards. So to do that, there's a bunch of different ways to import data. And so if you click on the data tab, you can say, from text or from HTML or from FileMaker or from a database query. We're going to go from text. And I already downloaded the data set and stuck it into a CSV file. So here it is. It's called car data CSV. And I'm just going to say get data. Now, we talked about CSV files, and CSV files are just these comma-separated value files. And so if we look at it, it's really kind of an ugly looking file. So it's basically columns that are designated by commas. And so you might have this thing that says delimited, and that's basically how they're spaced apart. And so if you just hit next after this, great. And it says how are they split apart. And so you'll see in the field as you're going through this what the data looks like after it's been parsed. So if we leave it as just tab, it looks still pretty ugly. But seeing how it's a comma separated value, so perhaps our delimiter is a comma. So if we click on comma, we'll notice that it pops out and starts to look more like a table. And so that's pretty much what we want our data to look like. So let's just go ahead and hit finish, and it'll ask us where do we want to put it. So let's put it into starting from A and starting from actually 2, because we're going to give this a bunch of titles. Cool. And so our data just got pulled in. Fantastic. So now we're sitting and we have a bunch of different data from 1985 car automobiles. And so what I would recommend if you want to kind of work along with this demo is go ahead and get that data set from UCI, pull it in, and just follow along. So you can always pause the video, you can always stop it, and kind of make sure that you're at where we are, and then work with it. Because kind of seeing somebody do it is useful, but doing it yourself is much more useful. So, all right, so now we've got this, but we also have some information about the text file that we're using. So everything from where it came from originally, how to cite it, and information about what the different columns are. And so we're going to use that information about what the different columns are and just fill that in so that we have a table that kind of is much more humanly readable. And so again, we're just generating this level 1 data that we've talked about. So we want this kind of humanly readable sort of data set that we can all kind of deal with and actually make sense of. So just going to grab that set of, actually I'm just going to type it all in. So it's going to take me a few minutes. So feel free to speed up the demo, or if it's going too fast for you still, pause the demo and just enter it in yourself if you're working through it. So let me just show you how I'm going to do that. So I'm just going to basically split my screen, and so that I have both pieces of information. Now you can just kind of see what I'm doing while I'm doing it. All right, so first one, symboling, and we're just going to go all the way through price. Great, so hopefully everybody has all that entered so that they're relatively happy with the data. And what we're going to do next is we're just going to organize that data so it's a little bit more, I don't know, just better. We're just going to create it into a table. So we're just going to select all the data and basically just say, hey, why don't we just insert this thing? Let me just close this down. Sorry. So we've got everything, all the information from our text file. So let's close that. And if you just click on Insert and hit Table, it'll reformat that and ask you where you want your table from. All right, so A1, perfect. Z1 or Z2 without 206, great. And my table does have headers, so you just hit OK. Yes, and much better. So now we have something that's a little bit more readable. And one of the cool things about converting something to a table using Excel is that it's now sortable. And so, for example, if we wanted to sort something by the number of doors, we could go and get all of the 2-door elements. So we'd say something like 2 and enter. And so notice the number of doors now is filtered going by 2 all the way down. Then it goes to 4 after that. Great. So the tables just give you a little bit more access to being able to do things with your data. All right. So as we mentioned before, one of the really critical pieces of dealing with data in a kind of getting an understanding of data is dealing with the histogram and kind of looking at, just histograms in general to kind of get a feel for how our data are arranged. All right, so now we have all of our data with nice columns and we have a nice table. So at this point, let's go ahead and build a histogram. So why don't we take this boar and use that and see what it looks like. So as I mentioned, I don't really know too much about vehicles, so we're just going to choose one and see what that data look like. So first thing we want to do, because this is kind of this level 1 data where it's kind of humanly readable, we're just going to scroll through this data and look at, kind of the range of data that are in BOR so that we can generate these different bins so we can kind of parse that data and organize it in a way that makes sense. So let's go ahead and take a look at it. It looks like we have a range that's going to be between 3 or 2.5 maybe and looks like about 4. And so we're just going to go by intervals of a tenth and create some bins. So all you got to do is go over and create another column. I'm just going to label this column bins, and we'll start off at 3.5. Let me just make sure that's a good range. 3.4, 3.1. So actually, it looks like we can go all the way down to 2.5. So let's just go ahead and start at 2.5 and just work our way down. 2.5, and obviously we could just do this. Just write a quick little script to do that. But I'm just going to do it manually because I'm going to do it that way. Great. So now we entered our bins, and we have a range of bins. And all we're going to do is basically ask for Excel to basically organize these data into bins in between. So one bin will be 2.5 to 2.6. Next bin will be 2.6 to 2.7. And it will just count how many elements in our BOR column fit into those criteria. And it'll generate ourselves a nice little graph. All right, so how do we do that? Well, we go over to Data Solver, and we say, go to histogram. Great. So click on histogram. Perfect. And we ask what columns we want to do it with. All right, so we've got AB, and we want our bins from all of AB. So bin range. Great. Let's click on AB. And then our BOR. Our BOR is going to be at column S. So we just click on that. Great. And let's just hit OK. See what happens. Oh, no. Histogram input range contains non-numeric data. All right, so something's going wrong. So somewhere in our data set, we have data that are not accurate, or not valuable to us. So let's cancel that and go ahead and look through our data. So if we look at our BOR column, cruising along. Oh, that looks good. Oh, no, there's some weird question marks here. So some of the automobile manufacturers, when this data set were made, didn't publish their BOR. So what do we want to do with these data? Well, we need to either get rid of them in some way or give them some sort of value that we can kind of deal with. So our bins range from 2.5 to 4. And so if we put these data outside of the bin range, but make them numerical, so Excel at that point will know what to do with them. They'll know that it'll look at them and be like, do you go into a bin? No. But at least I can read you rather than trying to read a question mark. All right. So let's make sure that there aren't any more in there. And we're just going to rerun our histogram. Great. So data analysis, histogram. And just to make sure that there are no possible chances that we're catching the title, we're just going to start from S2. That's going to be starting from there. And we're going to go all the way down to S206. And same with AB. So we're going to go from AB2. And then we're going to go all the way down to AB19. All right. So let's go ahead and make ourselves a chart style output. And there's a couple of other types of histograms that one can look at, Pareto's and cumulative percentages. Feel free to explore these on your own. So basically, these are summated histograms and ways to look at data as they kind of rise over time or over whatever type of input you have on your X value, so your bins. And so basically, you're going to end up with a percentage as they increase. So, but we're not going to worry about those for now. So let's go ahead and hit New Chart and see what we get. All right, cool. So there's our nice little histogram. And it doesn't look particularly abnormal, but it doesn't look like a normal curve either. So there's kind of these definite outliers down at this low range, some outliers at this high range, and there is a sort of a sloping peak, but I wouldn't consider this necessarily a normal distribution. There are enough data points in here, so 200 data points, that you should be able to start to see some sort of tendency towards the mean if you have a normal distribution. And this is one of the reasons that when we mentioned kind of low or kind of level 1 data, that analysis can be challenging. If you only have a few data points, maybe you have 30 data points, you may not have enough data to actually determine whether or not you have any normalcy between or generate a normal curve in your data when you look at it. But with 200 data points, you should start to see something that starts to look normal if it is actually normal. And this just my data intuition says this is probably not normal. And we kind of talked about some of those reasons why before. So, you basically have these different pressures. And in terms of manufacturing, you know, vehicles are limited by how big they can be and how much compartment space there are for the engine. And so you kind of limited as to how you can generate and what bore size you can generate. In addition, you're going to be having conversation with other manufacturers as who's generating piping for your system, because you're probably, as a car manufacturer, you're probably getting that from somewhere else, so they have their own constraints. And so the majority of car manufacturers are going to get their materials from a few locations, and so there's all these different fun constraints. So, but it's good to understand what our data look like. All right, awesome. So that's part one, just kind of getting a sense of our data using the histogram. Highly encourage you to do this for pretty much any type of data set that you're looking at. You basically want to get some understanding of it. So let's go ahead and do a little bit of data analysis now. So one of the types of data analysis that we might want to do is understand whether or not there's a correlation between two different events in our data set. So we can go back over to our data and take a look at a couple things. And we're going to choose something that I think should have a correlation. So of our data that we have here, well, we've got things like horsepower and engine size. Okay, so that makes sense that there's probably a correlation between those two things. So what does a correlation mean? So a correlation means that as you go up in one thing, you go up in the other thing. Or if you go down in one thing, you go down in the other thing. And so one event is correlated with the other one. Right, and so I think many of you have heard this kind of term. Correlation does not necessarily imply causation. So there's definitely, it's a trend, not a causal relationship. So A goes up, B goes up, sort of event. Why? Who knows at this point. So let's go ahead and take a look at that. And so how we would do this is we would generate a scatter plot. And so again, a lot of these tools are really common, and so Excel pretty much has them all set up for us. And so we can just go over to Insert, and then, hey, look, there's a whole bunch of recommended charts. Wow. All right, so scatter plot, X, Y scatter. Great. Let's just go ahead and click on that. And there's a scatter plot. Fantastic. And we get this nice little chart that's already pre-made for us. We want to change our data, so we want to click on this thing that says Select Data up here. So just hit Select Data. And we can just choose what we want to put in. So things that we want to put in, we said we wanted to go with engine size and horsepower. So let's figure out where engine size is. Where did I put engine size? Engine size, here we go, Q. Great. And then horsepower. Great. And so Excel will just basically, you click on the column type, and if it's in this table format, it knows that it'll get rid of the header for us. Let's just subtract a bunch of these things. So there we go, perfect. And hit OK. See what it looks like. All right, so now we have this chart of different, whoops. Come here. Sorry, I meant to grab the thing and make it bigger. Recenter that. All right, so now we have all of our data points sitting here on this nice chart. So on the y-axis, we have engine size, and then in the x-axis, we have horsepower. All right, so let's take a look at this and think about what it means. So it looks like there's this general trend that's kind of going upwards, right? So our dots have some sort of potential trend. So how would we actually look at that? So basically what we want to do if we're trying to look at correlation between data and between two different axes is we just want to say, hey, what's the best fit line for this? Is a really common way to do that. And so again, this is kind of a pre-built strategy. So if you just right click or control click onto one of the dots, doesn't matter which one, it'll ask you, hey, what do you want to do with this thing? Well, you can label it or whatever, but all we want to do is add a trend line. All right, great. So Excel already knows how to do this. You can dictate what type of trend line that you want to use. Linear is a good starting point, but you could play around and try to do a polynomial fit and see if it fits best. whatever you want to do. But as you understand what those different trend lines mean, or why you might want to use them, for example, you might want to use a logarithmic trend line if you think that there's some sort of event that's kind of going to cause some sort of asymptotic relationship. So basically, as you go up in one structure, if you go up in A, eventually B is no longer going to increase, but it's still going to correlate along this line. So so no matter how big you get the engine, your horsepower is not going to go up, or vice versa. So, all right. So we've got this trend line, and then what we want to do is we want to ask it to display a couple of things. So displaying the equation as well as the r² value. So the r² value is basically how well does this thing correlate. So how much do these plots or these dots scatter from this line? If something, every time you went up in 1 in type A and it always went up exactly 1 in type B, you'd have a perfect correlation. So every single line would lie on that dot, right? Or every dot would lie on that line, sorry. But most things don't have a distribution that's perfectly correlated. So here we have a correlation, and it tells, as I said, a value of 1 means that it's perfectly correlated. A value of 0 means it's uncorrelated. All right, we also have a slope. And so the slope of our line is positive. So where lines have slopes, and lines have this equation mx plus b. So where m is the slope of the line, and b is the y-intercept. So the slope of that line is basically going to tell us whether or not the correlation is positive or negative. So you could have a slope that was like every time you went up 1 in A, you went down 1 in B, right? So that'd be a slope of a negative slope. So, all right, so awesome. So this is another piece of data analysis. So if you were a car manufacturer and you're like, okay, so we really want to build a car that has 300 horsepower, and we're trying to figure out, how much material we're going to need and kind of what type of engine we're going to need. One might build this type of data and look at what cars are already out there and say, all right, so we're going to probably be estimating something in the range of 200 to 300, or I guess we look at the line here. So here's 300 horsepower and somewhere around the 245-ish range. So we could plug it into our equation and actually figure out the exact value if we wanted to. All right, so that's the value of trend lines. Again, a super common application. And one of the cool things about trend lines, it's a really common first machine learning strategy. So basically, one way to machine learn stuff is basically do all these calculations. So you calculate a line and be like, okay, so how far is this dot from that line? How far is this dot from this line? How far is that dot from the line, et cetera. And so you can throw that into a computer program and you just start drawing lines. And so you draw your first line straight across and then be like, oh, these dots are really far away from it on average. And then you start to just change your line around, just doing this kind of hypothesis iteration sort of strategy until you have a best fit. So something to kind of think about like using this understanding of what these trend lines work or how these work to kind of get yourself kind of this core basic into some of the machine learning structures that you're going to maybe want to dig into later as you become more of an experienced data scientist. All right, cool. So there's two different techniques that we've looked at. The last thing I want to do is I want to run a t-test. And so what is a t-test? And a lot of people kind of get lost on t-tests. So I'm not going to go too far into it, but basically it's a way to compare averages between two different sample sets. And depending on how your data are distributed, if they're normal, you might want to use a student t-test, or you might use a Welch's t-test, or these different structures, depending on what your data look like, to kind of figure out whether or not two data sets are actually the same type of thing, or if they're two separate types of things, is a really common use. And so maybe we want to go ahead and take some data and look at number of car doors and, I don't know, wheel length, wheelbase length. So, and our null hypothesis in this case is going to be something to the effect of, hey, it doesn't matter how many car doors you have because wheelbase or wheel length is going to be not correlated with it. So they could both be from the same data set. So let's go ahead and take a look at that and see how we would attack that using Excel. I'm just going to delete this guy. Now we know our scatter plot. All right. So how I'm going to do this, we already sorted this by number of doors. And so let's just go ahead and grab our wheelbase and go all the way down till we get to 4 doors. And we're in. Cool. Great. So I'm just going to move this over into another column. Great. So there's wheelbase. We're going to just name this part wheelbase, and we'll call it wheelbase 2-door. Great. And then I'm going to grab the 4-door variant. So just going back over. All right, wheelbase. And it was 90-ish. Cool. All right. Go down, grab all these guys. Oops, come on, scroll. Lots of 4-door cars. And there's a couple cars that have questionable numbers of doors. I'm going to go with their Jeeps, but I actually don't know. A Dodge and a Mazda. Why don't they know how many doors they have? Doesn't make sense, but whatever. All right. So we'll just go ahead and move that over there. We'll call this one wheelbase 4-door. All right, great. So now we have 2 data sets that we want to compare whether or not they're the same or different. So our null hypothesis is that it doesn't matter how many doors that we have, or that they are going to fit and look the same. And so let's go ahead and do this. So now we're just going to go over to data. Again, go to our data analysis, hunt down. So we're going to say, hey, our assumption is that we're going to have a t-test, and we're going to assume unequal variances. Great. All right. And just so you guys know, I'm going to do something a little bit, this whole part is a little bit duplicitous. So just be aware that something else is going to happen at the end of this. All right. Cool. So variable range 1 and variable range 2. Great. All right. So we can hypothesize that there's going to be some difference between the 2 of them to start with. Right now, our hypothesis is that they're exactly the same. All right. And then let's just run it. So we're going to create it as a new worksheet. Cool. All right. So we get this data back. And what this data looks like is it tells us the means of the 2 variables. So the 2-door sample has a mean of 95. The 4-door sample has a mean of 101. And also how many samples are in each group. So there's 89 samples and 114 samples in the 2 different groups. And once you start to get bigger sample sizes, again, it's easier to kind of look at the means. So the more samples you have, the more tendency there is to kind of go to what they're supposed to be. And so if you had 1 million samples or an infinite number of samples, the mean would be whatever the population is, right? So if you looked at everything in the population, you would know exactly whether or not that thing is the mean or not. But right now we're taking up subpopulation, so a sample from that population and saying, this could be the mean or this couldn't be the mean. So we kind of want to know how many observations there are. So we get these values down here. So these values are these p-tests. So these p-tests or these p-values are basically the probability that these 2 things are the same. And notice that they're 10 to the negative 12th ranges. And so what that's basically telling us is that there's a really, really small chance that if you just grabbed 2 random groups of the same type of object, that you'd end up with these distributions. All right. Now, why? So that's really cool. It's a super useful tool. T-tests are great. Definitely take some time, play around with some different t-tests, read up about them when you're done with this video. But what I did that was duplicitous here is we didn't look at the histogram of these things, and the way t-tests are implemented on Excel they're based on these student t-tests, and they need normal distributions. And so we don't know that these things were normal distributions before we actually attacked it. And in fact, we have some evidence that car manufacturing is not normal. And so this is kind of the example of knowing the tools that you're using and jumping in and really addressing some of these really um, interesting problems is really fun. So go ahead and jump into machine learning, but don't forget to really emphasize the basics so you don't make a pitfall and make a mistake like I just did, where you're saying, hey, this is what these analyses tell us, when that's not really what these analyses tell us. So hopefully that was all helpful. And with that, we're really excited to have had you join us for this program, and hopefully you'll stick with us through Power BI and then integrating R with Power BI. But if not, there are some really excellent tools out there to kind of expand your data science horizons, kind of in a structured format where you're learning, the statistical core, going through and learning how to program in Python, learning how to program in R, and then applying machine learning strategies from that point. Because the goal of this is really to kind of give you the overview of what data science is. So hopefully you enjoyed it, and I definitely enjoyed having you here.